Are you needing some mathematical relief? Then today is your day in Algebra 1. We have been simplifying radicals, multiplying radicals, we have been dividing radicals. Today we're just adding and subtracting radicals. And really I do think this is an easier lesson, but there is some sense behind doing some of that other stuff first. In ways it might be a little more complicated, but in many other respects I think it's actually simpler. And I know you guys are going to do really well with this particular section in our chapter on radicals. Again, we're just going to be adding and subtracting radicals. Not too hard of stuff. And part of why I really like this one is, look, I have nothing in upper left and upper right, and you probably know what that means by now, that there really aren't any formulas about which we have to be concerned. It's just basic math really that we're doing, just involving terms with roots, and mainly numbers with roots, even though we'll have some variables as well. Okay, so let's start with just some really easy stuff on number 1. On numero uno, let's do 4 square root of 3 plus 2 square root of 3. And one thing I do want to point out to you in the outset is that you can only combine, meaning add or subtract the numbers that are in front of the radicals, okay, if the radicals themselves are the same. Meaning it's the same root, 2, 2, you can't have to the 3 that's you're taking the root up to the second power or the square root, and then 1 that you're taking to the third power or the cubed root of it and combine them. You can't do that. It doesn't work. So it has to be to the same power, which these two are. They're both understood to be to the second power. The roots are being taken. And the other thing is the numbers themselves underneath the root, or the radicand, you might recall the terminology. The number underneath the root, or the radicand, has to be exactly the same. And look, we have powers that are the same, both understood to be 2. And we also have exactly the same numbers underneath the square root symbol. And guys, when that's the case, that root of a term is going to act as the base. Okay? It's going to be just like a variable to the same power, or just like a denominator. And when you add or subtract, remember, you don't change the power. In the case of variables of certain powers, when you add or subtract fractions, you don't change the denominator, right? When you have a common denominator, you keep it the same, and you just address the numbers that are in front. So because I have the same base, square roots of 3, and I cannot simplify those anymore, all that I do is just look at these first terms, 4 and 2. And I'm going to keep my base, which is a square root of 3. Okay, I keep my base. That's like my variable to a power. That's like my denominator in fractions when I'm adding and subtracting. And now all that I do is add or subtract, in this case add, the two numbers that are in front of that square rooted term. What's 4 plus 2? 4 plus 2 is 6. Therefore I am done. 4 square root of 3 plus 2 square root of 3 is simply 6 square root of 3. Guys, that's so easy a caveman or a woman can do it. So that's not a big deal. Now, you understand that things are a little more complicated when you don't have the same base. But we've learned by this point that we can break up these individual terms that are being rooted, in this case square rooted, and we can actually end up coming to a common denominator between some of, and in certain cases, all of the terms in our problem. And this first one, what I'm going to do is we're going to break down 45 into its simplest expression, that is square root of 45. But to do that, I want to ask myself, is there a factor of 45 that is a perfect square of itself? Is there a factor of 45 that's a perfect square? You're right. Yes, there is. And what is that number? 9. What times 9 gets me to 45? 5. 9 times 5 is 45. Therefore, I can rewrite this first term as square root of 9 times 5, because that's the same thing as the square root of 45. Okay? Plus, can I break down 18 further, the square root of 18? Certainly I can. Is there a perfect square that is a factor of 18? There is. And once again, that number is El Nino. No, it's 9. And what times 9 gets me to 18? Dos. So 9 times 2. I'm going to write it that way. And that's okay because 9 times 2 is 18, and therefore the square root of 18 is also the square root of 9 times 2. Same thing. Now, keep my sign. Can I break down square root of 5 any further? I cannot, and the reason for that is 5 is a prime number. You can't go any beyond what a prime number by definition is. So I just keep minus square root of 5. Now, what I'm going to do is I'm going to pull out of here the square root of 9, because I can just move that outside of the parentheses because I know what the square root of 9 is, being a perfect square. 9 square rooted, or the square root of 9, what times itself gets me to 9 is 3. So I'm going to pull that 3, square root of 9, which is 3, I'm going to pull that to the outside of the square root symbol, cross that out, and with what am I left underneath that square root symbol? I still have 5. Plus, okay, what can I do with the square root of 9? I know what that is. That's a perfect square, and I just did it here, so I'm going to pull that out as a 3 once again, cross that out, and what do I have left under the square root symbol? 2. Alright? Can I do anything with that minus square root 5 as far as pulling anything out to the outside? No, it's as in lowest of terms as you can possibly get. Now I do want to ask you this though. What is the understood number between that negative sign and that square root symbol that I do not see? What's the understood number that we just don't write? It's kind of like if I had the variable x. If it said minus x, what do I understand is between that negative sign and that x? A 1. Same thing, guys, with a root symbol to any power. If there's nothing in front of it other than a minus or a plus, it's understood that there actually is a 1 in front of it. So for simplification purposes, not for my final answer, I'm going to write it that way. Minus 1 square root of 5. Now, do I have any terms in common, meaning the same base, the same term being rooted to the same power? Yes, not all of them, but this one, 3 square root 5, has the same base of minus 1 square root of 5. Okay, and so I can rewrite, I know I'm running out of space here, forgive me for that, but I can write my base, square root of 5, and just add or subtract my numbers that are in front of that. What's 3 minus 1? 3 minus 1 is 2. Keep my base, the common base between those two. I'm just combining like terms here. So I have 2 square root of 5. Now I have one term left over. Can I combine that with this term, a square root of 2 as a base? No, because this is a square root of 5. They're both prime and they can't be broken down any further. And so I have 2 square root of 5 plus, and it's just not on the same, normally I'd write it on the same line, but I don't have the space to do it, you understand that, plus what I have left, 3 square root 2. And that's my final answer, 2 square root 5 plus 3 square root 2. I'd love to get it down just to one term, but I can't do it because I don't have the same base. That's as close as I can get to doing so. But I did combine 2. I had 3, and now I'm down to 2. Okay, let's do number 3, which is dealing with a cubed root. Okay, we're going to be dealing with a cubed root in number 3. Similar, but it's what times itself instead of what times itself. That's the difference between a square and a cube. Same thing with the roots of each. So, -8 cubed root of 5. Guys, can I break down a cubed root of 5 any more than it already is? No. it's in lowest terms possible, and so I'm just going to rewrite negative 8 cubed root of 5. 5 is a prime number. Can't do any more with that because they're being added and subtracted. Now, if they're being multiplied or divided, as we did the last 2 class periods, that's a whole different ballgame. But they're being added and subtracted, so we can't just mesh them all together. Okay, plus 9, okay? Now, 40, cubed root of 40. I need to break that one down, I'm pretty sure, aren't you? Is there any number that you know to be a perfect cube? And remember, start small because cubes get big in an exponential, no pun intended, hurry. Is there any perfect cube that is a factor of 40? How about 2 times 2 times 2? 2 times 2 is 4, and 4 times 2 is 8. And so 8 is a perfect cube, and when you take the cubed root of that, you get 2. That's why it's a perfect cube. Okay? Is 8, though, a factor of 40? Yes, it is. What times 8 gets me to 40? That's 5. 8 times 5. So I have 9 cubed root of 8 times 5. I've done that because I know I can pull that 8 just right outside when I go that next step. Okay, for my third term, minus 2, this one's a little tougher here. Cubed root of 135. Do you know a number that is going to be a perfect cube of 135 as a factor? Well, let's get out our calculators, okay, and do this in an easier way. I'm letting you guys use your calculators in this chapter, and for good reason. It's not going to be 8, because that would be an even number, wouldn't it, no matter how I sliced or diced it. So I'm not even going to mess with 8 and waste my time. But my next one up as a potential, because 2 cubed is 8, well, my next one up would be 3. What's 3 cubed? 3 times 3 is 9. 9 times 3 is 27. Let's punch that in and give it a shot. Remember, you want to start small with cubes and cube roots because those numbers get so large in such a hurry. So 135 divided by a perfect cube, which is 27. Looky there, it is a factor. So 27 and 5, let's use that one. The reason for that is we can easily pull 27 out whenever we get to the next step. Okay, so I'm going to have under my cube root 27 times 5. Okay, let's do that next step. We already know we can't do anything with our first term. Let me get out of your way, Hannah, so you're not belly aching at me, okay? Negative 8 cube root of 5. Cannot simplify, we know that. Now this one, plus 9, okay? But what can I do with the cube root of 8? I can pull that outside of here and I can multiply it by 9. Okay, but I have to make sure I get the right number. It's not just 8 that I pull out. I have to take the cube root of 8 to get that out from under the cube root sign and multiply it by 9. And so what is the cube root of 8? That is 2. And so I'm going to have 9 times 2 cube root of what's left underneath that cube root sign, the number 5. Minus 2, okay, but 2 times what? I put this in the factors of 27 and 5 for a reason. Well, let me not swoop down so much here so I don't get in my own way. How about that? What's the cube root, guys, of 27? The cube root of 27 is 3, because 3 times 3 times 3 gets me to 27. I can pull that out to the outside of that cube root symbol as simply the number 3. And don't forget, keep your multiplication sign as it was under here. It has to continue to be multiplied, inside or outside. Okay, and then I have remaining the cubed root of what number? 5. Now I need to do some simplification. Negative 8 cubed root of 5. That remains unchanged. Plus, what's 9 times 2? 9 times 2 is 18 cubed roots of 5. Minus, so I don't have to worry about the negative or the minus sign. What's 2 times 3? 2 times 3 is 6. Keep my cubed root of 5. Now, do I have any Any terms that are in common, meaning they have the same base? Oh, most certainly. This one is wonderful, guys, because I have 3 terms. Not 1, not 2, but 3 terms that have exactly the same base. So in the end, I'm going to go from 3 separated terms all into 1 for my final answer. Now, this much I do know, that the answer is going to be in the base of the cube root of 5. So I'm just going to go ahead and write that because that's not going to change. It's just like adding or subtracting fractions. Your denominator stays the same. Just like adding or subtracting variables with exponents, you have to have the same base, same variable to the same exponent or the same power, and that doesn't change. It's just your numbers that change. In a fraction, it's just your numerators that change. Well, same thing here. It's just your numbers in front of that base of cube root of 5 that are going to change. Okay, what's negative 8 plus 18? I prefer to say it this way, it's easier. What's 18 minus 8? 18 minus 8 is 10, okay? And what is 10 minus 6? 10 minus 6 is 4. And so my simplified answer as one term is 4 times the square root, okay, 4 times the square root, or I'm sorry, the cubed root, easy to do, isn't it, of 5. Okay, now let's do number 4. Number 4 is 2x times the cube root of 50x minus, we're adding and subtracting radicals, minus 5 times the square root of 8x cubed. Okay, so what I'm going to do is keep my 2x. That doesn't change. We're good there, correct? What can and what I do need to change is what's underneath that square root symbol. And I first want to ask myself in breaking down 50x, and let's just start with numbers first, okay? Numbers first. Is there any perfect square that is a factor of 50? Is there any perfect square that is a factor of the number 50? There is, and that number is, I'm bad at the drum roll, terrible at Spanish R's, I cannot roll my tongue, so 50, the factor that's a perfect square is 25. What times 25 gets me to 50? Dos. So 25 times 2. Okay, and then I'm also going to tack on there times x. Don't forget about your variable, but we do that after we deal with the numbers, the coefficients. Okay, now minus 5 times the square root of. Is there any number, let's break down 8. It's not a prime number, so we need to break it down. Is there any number that is a perfect square as a factor of 8? There is, and that is cuatro. 4, and what times cuatro gets you to ocho? Dos. So 4 times 2. Now guys, don't forget about your variable, which there are 2 ways of writing it. You can either do x cubed, or if you prefer, if it's easier to you, remember we've done it both ways. If it's easier, do x times x times x. I'm okay with that. And whatever you find simpler, that's terrific. Now, let's see what we have going on right here. Okay? And as a matter of fact, let me do it on this one. I think it is, for your guys' purposes, I think it's a lot easier just to put out the variables x times x times x, okay? Let's do it that way. We can do it either, but I think it'll be easier, so let's try it. Alright, so what can I do as far as rearranging? Square root of 25, what is that? I know the square root of 25 is 5. And so out here with this 2x, I can multiply it, keep your signs of being multiplied, all this together right here. This term, all this is multiplied in the second term, even though this is having this subtracted from it, okay? But 2x times 5, so I moved my square root of 25, which is 5, to the outside of the square root. That's why I did that. And I still have underneath that square root symbol what? 2 times x, which is simply 2x. Minus 5, okay, but can I move anything to the outside? Yes. What's the square root of 4? Square root of 4 is 2. So I'm going to multiply that negative 5 times 2. Now, remember, whenever you have the same term and the square root, or a root to the second power is being taken, every time you get to a count of 2 of the same term, you can cross the 2 out and move 1 to the outside. Okay? I have 1, 2 x's. I know I have 3, but I have to have an even number if it's 2 out here. And so I can move these 2 x's but combined into 1 out here. And remember the math behind that, so times x on the outside. The math behind that is x times x is x squared. Well, if you take the square root of x squared, how many x's do you have left? Divide those exponents. 2 divided by 2 is 1, or x to the first power. And that's why mathematically you only have 1 out. Okay? Same thing here. I had a 4. Really, that's 2 times 2. Well, I cross that out, those 2 2's, and I move it to the outside as a single 2 because 2 times 2 is 4, and the square root of 4 is just a single 2. Does that make sense? Remember, that's the math behind it. Okay, but what do I have left? Square root of, I can't do anything with a 2 and 1 of the x's. Alright, so let's simplify. What's 2x times 5? 10x square root of 2x. Minus, so I can forget about the negative sign, minus, what's 5 times 2? 5 times 2 is 10. And what's 10 times x? 10x. And then lastly, base square root of 2x. Wait a minute. 10x square root of 2x minus 10x square root of 2x. If I were to keep the base, and adding or subtracting of square root 2x, guys, what's 10x minus 10x? I just deal with the numbers in front then, if it's the same base, which it is. What's 10x minus 10x? 0. So I really don't have an answer of 0 times the square root of 2x. I just have an answer of 0. That is my answer. And that's not no solution. You know, 0 with a line through it circled, that's just a 0 that's circled. My answer is 0, because 10x minus 10x is 0. And anything multiplied by 0, like a base of square root of 2x, is still going to be, goose egg, 0. One more left to do. Now this one is kind of fun. Maybe. It's pretty challenging, okay? So make sure that you pay attention. You stay up to par here with me, all right? Number 5. Square root of x squared. Okay? Square root of x squared. I'm just going to rewrite that for right now. Square root of 2x squared. Okay? 2 is a prime number. We'll talk more about the x squared in just a moment. Plus 75 x to the 4th power. How could I break down 75 in such a way that I could have a perfect square as a factor of 75? Once again, our friend, our family member, it feels like by now, 25 is helping us out a lot. So let's do 25. What times 25 gets me to 75? 3. Okay. Let's not forget though, x to the 4th, and this time let's not write it x times x times x times x. Let's just leave it as x to the 4th, and we'll do it the other way this time. All right. For my next one, minus 2x squared. Square root of 3. We're going to keep that, correct? You can't break down 3, square root of 3, any more than what it already is. That's a prime number. Minus x square root of. How can I break 18 down into a couple of factors, one of which is a perfect square? We did this, eeny, meeny, miny, right there. Bzz, stinger, beep. So we're going to do 9 times 2 underneath that square root symbol. You comfortable with that? Peachy. Okay, now, what can I move to the outside of each one of these, if anything? Square root of 2x squared. Can I move anything to the outside? Careful here, not in number, but in variable and exponent, yes. Now remember, this is understood to be a square root. And whenever you have a variable and a power to it, like x squared, how do I take the square root of x squared? I divide the exponents. And so I divide that 2 by the 2. What's 2 divided by 2? 1, or x to the first power. And so I can cross out the x squared, not the 2, but the x squared, and I can move that as x to the first power because 2 divided by 2 is 1, okay? And so I can have just an x to the first power on the outside of that first term, and I'm left with only now a 2 underneath the square root symbol. Does that make sense? And it's the same thing we did up here. If I had x times x, I could see, well, that's a square root, and there's a duplicate of terms, and so I can cross out the 2 x's, and I can move 1 to the outside. So it's the same process, it's just 2 ways of looking at it, and so we're doing it the other way in this last one. Now, plus, what's the square root of 25? That's 5. And so I can cross that out and move the square root of 25, which is 5, to the outside of the square root symbol. Can't do anything with the 3, correct? Can I do anything with the x to the 4th power? Yes. And remember, this is a square root, understood, and so I can divide that 2 into that exponent of 4. And what is 4 divided by 2? 4 divided by 2 is 2, and so I can cross that out because evenly it goes into it, and move the answer to that division I just did as the exponent to that variable on the outside of the square root symbol. Okay, or in other words, if I had x times x times x times x, I could see, well, there are 4 of those, and so for every time I have 2, I can move 1 to the outside, but since I have 2 sets of 2, I can move a total of 2 x's, meaning to the second power to the outside. Okay, that's from where that comes. Or I like it this way because it's simple division. 4 divided by 2 is 2, and so just move it to the outside as x squared. I like the shortcut myself, but you do whatever you're more comfortable with. All right, with what am I left underneath the square root symbol? In other words, with which I can do nothing. That's the number 3. Okay? Minus 2x squared, square root of 3. We can't do anything with that. Now, minus, it's an x, okay? But, can I do something with that square root of 9? Oh yeah. I can cross it out. What's the square root of 9, guys? 3. And so I can move just a 3, no square root attached, to the outside of the square root symbol. What is 3 times what's found outside of that square root symbol in that term? 3 times x. That's 3x. And with what am I left underneath the square root symbol? The number with which I can do nothing, 2. Okay? Now I need to ask myself, do I have any terms that have a like base? And I do. The first term and the last term are in common. Okay? I have the same base of square root 2, so I keep that. That's like my denominator in a fraction. Cannot change the base when I'm adding and subtracting terms. But what I can change are the expressions out in front of those 2 square root terms. I have positive x and negative 3x. What is x minus 3x? Think about it just a second. What is x minus 3x? I have 1x and I take 3 away, and what do I have? Negative 2x. Square root 2, same base. Negative 2x square root 2. Okay, with the 2 terms, I'm done here, let's not look at those anymore. The 2 terms I have remaining, is there any commonality found there? Yeah. Commonality is they have the same base, square root of 3. And so I'm just going to go ahead and write square root of 3 right here. But how do I write what's found in front? Well, I just look at those two terms. That's a positive. I should have circled the sign with it. That's a positive 5x and a minus 2x squared. Or positive 5x squared, I should say, and a minus 2x squared. They have the same base on the outside, which is important too. These have the same base of x on the outside. Okay, these also have the same base of x squared on the outside. And so I know it's going to be some sort of an x squared because I just deal with the numbers themselves that are in front. What is 5 minus 2? Well, that's pretty simple. That is a positive 3. And so guys, my final answer here, this big long problem, as our granddaddy of all finales, is negative 2x square root of 2 plus 3x squared square root of 3. So what do you guys think about that? I know, in ways that I think it may be a little bit more complicated because of all the different bases and breaking them down. But if and when we get comfortable with that, which I think we're getting more of that now, the more comfortable we get with that, then really all that's left in these is just addition and subtraction. And so that's extremely simple, the most basic of all math. But it's taking the complicated and going all the way back to the beginning. And you guys see why math is so important, that you don't miss anything along the way. Because it's not only day after day it builds upon what you learned before, but it's also year after year that it does so. Guys, that's all the math for this week. Take the weekend, relax a little bit. Unfortunately, I do have to give you some bad news in that our second quiz is assigned today. But outside of that, however, oh no, I'm sorry, I have good news. We assigned a second quiz yesterday, didn't we? I'm behind, so no new quizzes. Relax, enjoy the weekend, other than just making sure you get that done and it's ready to turn in on Monday. All right, I will see you guys then.